Hello all. Welcome to lecture series of process automation for BTech students. Today the discussion topic is basic PLC programming, where we are going to discuss what are the components used in basic programming, basically the ladder diagram programming, and the different examples like logic gate, implementation of logic gate using a ladder diagram for a practice purpose. And then we are going to discuss some advanced PLC programming features like latching, memory, timers and counters. So we'll start with a basic introduction to the components which required or the elements. So basically in programming, in ladder programming, we required the buttons. So we have already discussed in a previous lecture series that there are two types of buttons are available. One is a push button and second one is a toggle switch. So toggle switch are acting as an sensors. But for today we are going to discuss regarding the push button. So basically there are two types of buttons or two states of push buttons are there. First is normally closed, that is abbreviated as NC, and second one is a normally open, normally close and normally open. Okay, so if I want to draw it in electromechanical way, so NO and NC. So normally open means without any supply, without any excitation, the button is in normally open condition. And when I say normally closed means button is in normally closed condition. And when I give any excitation like 0 and 1, so basically one logic if I provide, so the state of NO became close, that is C, and the state of NC became open. Okay, now when I say normally open, that time I can draw it like this. So suppose this is my supply, positive and negative. Okay, and I have a button, push button with me, which is having a coil which is going to energize, and I have a push button. So this is nothing but normally open. So when I give some force on this button, okay, it will connect, it will make a contact and the circuit is completed and the supply is flowing. Now in case of NC, I can draw it like this. So here, so basically in normally closed means button is in closed condition, the it is already connected and the supply is flowing through the circuit. But when I push this button, NC button, it will open, the state is changed from NC to open, and it will disconnect the supply, so this is the basic what I can say components or elements required for ladder diagram. And one more is output. So here we can write it like this. In ladder diagram, in bracket you can write output, or you can give q0 q1 as per your convenience. So the meaning is we have a coil which is going to energize. The output indicate a coil which is going to energize after getting a supply, okay. So if I want to draw any ladder diagram, so I can say that I have a two vertical lines which indicate positive and negative supply. Then I have a input either NO or NC contact, okay, on left hand side, and on right hand side we have a output, that is Q0. So based on the what I can say, based on our condition, output can be on or off. output can be on or off. So here I can say that, just a second, I'll change the color. Yeah, so this line, horizontal line, is called as rungs, 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 and this is positive and this is negative supply line. Okay, and here I can say that it is also called as a network. It is also called as network. Now when I say PLC, so on output side, just remember, on output side PLC gives you only connectivity. PLC gives you only connectivity. It will not give you the supply. It will just give you the connectivity. Okay. Now, when here, for getting a better exposure, for a ladder diagram, we can go through a different logic gates. So basically, here for this session, I'm going to go through one or two logic gates only, so that you will get a better idea how you can implement a ladder diagram of a logic gates in a simpler way. So basically, first I'll take the what I can say, the AND gate. Okay. So in AND gate, how to implement? So to implement a ladder diagram, first we have to write down the truth table. So here A is one input, B is another input, and I can say Y is my output. Y is my output. So you know the truth table of AND gate is inputs are 0 0, 0 1, 1 0, and 1 1, and the output is 0 0 0 0 and 1. Okay, so now I can draw it like this. So this is my ladder diagram. We have only one output, so minimum one rung must be there in your ladder diagram. Minimum one rung has to be there, because you have a one output. So this is the output. Now we are more focused on the inputs at which the output is giving you the output as 1. The output is 1 for input that has to be implemented using a ladder diagram. So now if you see here, when A is 1 and B is 1, Y is 1, that is output is 1. So I can write it like this. So when I am going to use a normally open A, normally open B, okay, this is A and this is B. So when I am going to provide here, for example, this is my NO contact. Okay, this is my NO contact. When I am going to provide a 0 here as a logic, there is no change in state of NO switch push button. Means if it is NO, after giving a 0 as an logic, it will become NO only. Okay, but if you supply one logic 1 to NO, that is normally open, so normally open button will going to or will get close, and or I can say that normally open became close. Normally open became close. Okay, so if I provide a logic 1, the NO or NC going to change their state. So basically, if you see here, in this case, if I provide A is equal to 1, this NO became close, so supply will flow through A. Then when B is 1, so B is 1 means again this B is going to change the state from NO to close. The supply is moved toward the output, and the circuit is completed and output is on. Output is on. Okay, so this is the ladder diagram. Similarly, if you check this ladder diagram for these three cases, you will get a correct output. So for example, 0 0 means there is no change in state. So if there is no change means it is normally open, connection is not going to close. Okay, you will not get any output, that is 0. Similarly for B, if B is 1 means BNO became close, but before that you have a which is normally open, so connection is not completed. Similarly, in case of this, A is 1 but at that time B is 0. So when I say AND gate, if you want to implement a AND gate using ladder diagram, so this is look like this. Okay, so this is A, this is B, and this is output. Okay, so these are the logic gates. Similarly, we what we can do, we can draw this with the help of electromechanical circuitry also. So for example, these are my two inputs AB. Okay, then I have one output. In case of output, I am going to use a coil, and this is a supply or a battery, you can say, and it is connected here. Okay, so here I can draw it like this. Normally open A is this, normally open B is this. Okay, so when I'm going to provide a logic 1 to A or B, both are closed and circuitry is complete, and the output or the coil is energized. Okay, output or coil is energized. So this is a logic gate. Now when I'm going for a second logic gate, that is NOR, we can say. So in case of NOR, NOR means not OR. Okay, not OR. So here I have A, B, and output. So again 0 0 is 1, 0 1 is 0, 1 0 is 0, and 1 1 is also 0. Again the same concept, just focus on the inputs which gives you the output as 1. So for 0 0 I got output as 1. So basically 0 0 means there no state change in the push button, but if there is no state change, I want my output as 1. So instead of using normally open, I'm going to use normally close inputs, that is A and B, and I'm going to write down the output. So if you see, if I provide this case 0 0 means there is no change, already it is all are normally closed, so supply will go through from positive to negative, circuit is complete, and output is energized. Similarly, any one became 1, any one, that is either A or either B became 1, that time Y is, that is output is 0, and when both are 1, again the output is 0. Okay, so this is the NOR gate implementation using ladder diagram. Again the same electromechanical display, if you want, you can draw it like this. So it is normally closed, so A, again normally close B. Okay, normally close B. Okay, so this is the basic uh, block diagram, we can say, or PLC programming. Now these are the logic gates. Now if we take any simple example, like you have a two output, that is A and B, and two inputs and two outputs, two input and two output. In that case, what you can do, you can take any example like A or B, or two output, anything if you want. You have to first go through the truth table. So you have to first draw the truth table, then you can implement a ladder diagram. You can implement a ladder diagram. Okay? So that part we are going to discuss in PLC programming, where the latching is comes in a picture.